Welcome to WXTV, your online source for weatherization training. In this episode, we'll team up with our master plumber Mike as he takes us through the ins and outs of boiler system safety and efficiency. In part one of this two-part series, we'll look at combustion air and drafting. Well, hey Mike, what are you up to?
Oh, hi Ben.
Good to see you.
Yeah, you too, Ben. Today we're going to be looking at boiler systems. We have a house here that has a boiler, and but we also have a water heater, and in this particular mechanical room we have a dryer, and it's kind of a confined area. We'll kind of look at the boiler like we do a clean test and tune on a furnace. Go through the boiler, do a combustion analysis, and those things. So we're also going to be looking at how our appliances draft when, say, the dryer's running and the doors are shut. Make sure that our system's drafting correctly. Okay, when I come into any mechanical room, I just take a general shopping list of what I see, what's going on. So we'll just start right here at the boiler. What we have here is a Volant 80,000 BTU input low pressure water boiler. Couple things I noticed right off the bat without digging into it is the vent damper back in this area right here has been, it looks like it's failed and someone has wired it open, so it's not even being used. It's just wired in the open position. The vent damper actually is an efficiency device. It helps increase the efficiency of this boiler. The combustion air for this actually comes in through this little area right here, and we have this grill here which doesn't allow for very much air. The actual free area on this is minimal, as you can see. Doesn't meet National Fuel Gas Code as far as the combustion air for this room. This is definitely going to be short the proper amount of combustion air for this room. Come down the line here, we got a water heater, a natural draft water heater that ties in the flue with the same flue as the boiler. The relief valve on this actually drops down into the crawl space. We have a laundry room. One of the things you want to avoid is rooms that have soaps. These soaps are, and the fumes from the soaps and the bleaches actually go through the appliances, and most manufacturers do not recommend having your fuel appliances in the same room as these chemicals, because it will deteriorate the heat exchanger on these. The other thing about this room is it's a fairly small room. The door's probably shut quite often. With the door shut and the dryer running, there's a really good chance that we create a negative pressure in here. One good thing that I notice here is right over here and in this room that's connecting is a carbon monoxide detector, which is it's a positive thing, that if this does backdraft and there is CO, that unit would catch that. Prior to doing any diagnostics work, what I want to do is check for gas leaks, and I go down into the crawl space in this house, check the gas leak, use this leak detector, check for gas leaks down there, check for gas leaks at the appliance. I basically do the same technique all the way through all the gas lines and make sure I don't have any leaks. If I do have leaks, I need to fix them before I continue with any of my diagnostics. One of the issues with this appliance is the gas line actually comes in through the back of this boiler, and it's very difficult to get to the shutoff, and even to get to the gas line. But it's back behind here, and I'm taking the combustion gas detector along that, trying to determine if I have any leaks, and it looks like we're good on this. If there was a leak, this thing would make a sound like this if a gas leak was detected. At this point, what we're going to do is we're going to try to put this room into worst case combustion, worst case CAS, combustion air zone. This tube actually goes outside. We're going to hook it to our DG700. It'll be our reference. We put the home in winter conditions. All the doors are closed, all the windows are closed. We will turn on any fans, exhaust fans, and we'll try to create what would be considered the worst case combustion air zone in here. So we'll turn on our DG700. We're going to read our pressure with respect to outside. Okay, we need to get baseline pressure. So we're on pressure. We're going to get baseline pressure. We'll start the calculation. Now this thing will go through a process and average out the baseline pressure. We'll let it go for 30 seconds or so. We select enter, and now we're at everything's with respect to baseline pressure. Okay, now so at this point I'm going to, based on this being a small room, small area, we'll have this door shut. We'll have the door back here shut. We're going to turn on this bathroom exhaust fan. We're going to turn on the dryer, and we're going to see what our baseline, or what our worst case pressure is with respect to outside in here. Okay, we'll turn on the dryer. And it looks to me like we're 5.5 pascals negative. If you look at BPI's protocol, if you have a natural draft boiler or furnace commonly vented with a water heater, which we do, then the limits for CAS are -3 pascals. So we're in excess of that. Our worst case combustion air zone, this is not a good situation. We need more air in this room. We can also even just take and use our smoke detector, or smoke, and put it by the flue. Okay, now I don't have this running right now, but normally this would not be backdrafting, and it's backdrafting right now. And what we're going to do is we're going to turn on our appliance, and it needs to stop backdrafting within 1 minute. Okay, we're still backdrafting. We're starting to get a little bit of draft, but we do still have some backdrafting effect here. Basically, we're past a minute and we still have backdrafting. This fails worst case combustion air zone test. While we're doing the combustion air zone testing, we want to make sure that we're not exposed to over 35 parts per million of CO ourselves. This unit's backdrafting. If it doesn't have a good burn, it's going to be kicking out some CO, and we would be breathing that CO, which is a deadly gas. So we want to be monitoring the CO in our ambient air where we're working, and make sure it's always below 35 parts per million. So we failed worst case combustion air zone under winter time conditions. So in order to move forward, what we need to do is we have to turn off the fans, we need to open the doors, and we need to see if we have draft under the best of conditions. And if we do have draft under the best of conditions, then we can continue. If we don't have draft, then we cannot continue with our diagnostics. We would have to solve the problem before we could continue with further work. At this point, we have all the doors open, the fans are off, and you can see we have our baseline pressure reading is definitely below the threshold. We're okay at this point, so we can continue. So at this point, we will get the actual draft reading from this water heater. We'll get the water heater fired. We can use our DG700 to get the reading. put our probe in our flue stream. Okay, and then we'll go over and watch our DG700 and see what our draft is. So we have -3 pascals of draft. If we look at our chart here, we're at 80 degrees. So we use this formula right here. This is BPI's formula. At 80 degrees, we need to have at least -0.75 pascals. We have -3.3 pascals. So we do have sufficient draft on this appliance right now. We want to let this appliance run for a while, get it to steady state. We've established draft with one appliance running. Now we're going to run the second appliance and make sure we have draft with both of them running. I'm just jumpering this to simulate a call for heat. And we want this appliance to run for 5-10 minutes, more probably 10 minutes with a boiler. It takes a while for it to heat up and hit steady state. We want it to run for a while, get up to steady state, and check for draft at that point. Just like with the water heater, we'll put our probe in here and we'll read our draft on the DG700. Again, we want to have at least -0.75 pascals, and in this case both appliances are running and we have -2 pascals, and as it heats up, the draft starts to pick up a little more and more. So basically we've established draft and we can continue with our diagnostics at this point. Okay, so we have a little bit of a problem with our worst case combustion air zone. It comes down to we don't have proper combustion air to this room. This little combustion air right here, right down here, just doesn't cut it. Okay. In order to, this goes to outside, but it's low and it goes out. If you want just one opening using the National Fuel Gas Code, you need to have an opening on the high, up high, and in this case, that opening would be would have to have 53 square inches of opening if there was a metal louver on the outside. That's about a 9-inch diameter circle going to the outside with a metal louver on the outside to supply the combustion air in here. When we're sizing the amount of combustion air we need to supply to a room, what we do is we take into account the BTU input of the boiler, which in this case is 80,000 BTUs. The BTU input of the water heater, in this case, is 40,000 BTUs. We have a dryer here. If this was a gas dryer, we would have to include the BTU input of the gas dryer. However, this is an electric dryer, so it doesn't come into the equation. So basically we have 120,000 BTUs of fuel gas that are going in, and we go to the National Fuel Gas Code and it tells us the protocol for how large of openings we need to the outside, or if we're using inside air, how large our openings need to be to get that combustion air to communicate with our appliances. That would be one simple solution, and then abandon this low one, because if you want just one opening, it needs to be within 12 inches of the ceiling. The other solution is we can have grills in this door. It would be 160 square inches, which is about 13 by 13, with a metal grill high, metal grill low on this door, and on this door right here, high and low, that goes out to this open area that has 6,000 cubic feet of volume that could be used for the combustion air.
Well, that's it for another episode of WXTV. Join us for part 2 of this series when we pick back up with Mike for the clean, test, and tune. And thanks for watching. WXTV, your online source for weatherization information, techniques, and expert advice.